everybody. So, the session today is about So it's about supercharging MySQL performance using ProxySQL. Mostly the agenda is the following. So quick introduction about myself, then a quick introduction about ProxySQL, what is ProxySQL, what it's used for, and then we're going to discuss about key features introduced in ProxySQL 2.6, so all the minor release of 2.6, 2.7, and then finally of 3.0. We are going to focus mostly on three areas, so performance enhancement, security improvement, and all the features in ProxySQL that have made possible simplify the management of ProxySQL itself and of MySQL traffic and so on. And finally, we're going to discuss about the two major features that has been introduced in 2.6 and 2.7 related to advanced features, basically, and those features were sponsored by two different users of ProxySQL, so two different companies using ProxySQL. Okay, quick introduction about myself. So I have my background in MySQL for 25 years or so, and I created ProxySQL something like 10 years ago. Initially was a side project, but then with time passing, has become one of the main proxy that you would use on MySQL infrastructure. I'm very passionate about performance, so this is the main reason why ProxySQL was born, as a frustration of being unable to actually control the traffic being sent to MySQL itself. So what is ProxySQL? So ProxySQL is initially started as a proxy for MySQL and all similar databases like the Cannaò server, MariaDB, and any other protocol, any other database system that use the MySQL protocol. It is able to scale a lot. So from the very beginning was designed to scale and to use millions of queries per second to be able to handle hundreds of thousands of connections. So like from the very beginning was designed to be extremely scalable. One of the initial features that has introduced were query write and query caching, but then it expanded to a lot more features like the ability of routing traffic, handling failover, and so on. It is used by a lot of enterprise, so it's quite I'm very proud of this. Including most of the larger companies are using it. Of course, not everybody, but unfortunately not everybody. It is going to change. Yes. So yes, I'm very proud of this that is being trusted by those large companies. So why they choose ProxySQL? Well, first of all, the main use for ProxySQL is because it allowed to scale. To scale a lot, because as was mentioned before, not just to have a lot of throughput, but because it's able to handle really a lot of connection. And this was historically one of the main limitations of MySQL, so it doesn't really scale a lot with the number of connection. And we have many users that are using ProxySQL at the beginning just for this specific features, so like reducing the number of connections to the database. But this is just the first foot on the door, because once they start using ProxySQL and they see all the other features that are available, they start exploring all those features. What I just said, that is able to drastically reduce the number of connection. This really, of course, really depends from the type of application and workload, but it's quite common to have a 100-to-1 ratio. Like for every 1 client connection, there is just one backend connection, because ProxySQL is able to understand the boundaries of transaction and identify when a single backend connection can be used by multiple clients at the same time. Then again, depending from the type of workload, it is also able to drastically reduce latency in a variety of ways. First of all, reducing the number of backend connection can improve performance, and also it is able to reduce a lot of the overhead of creating new connection all the time. And also, if we are using prepare statement, it's able to cache prepare statement metadata that this allow to drastically reduce the amount of queries sent back and forth between the client and ProxySQL. Always speak about performance, and the fact that it's able to scale out and use multiple server, multiple backend at the same time. It makes performance scale without any application change. Now, it's also used for reliability. In fact, this has a lot of algorithm that is able to detect when a backend server failed, so it's automatically able to detect the where has to redirect the traffic once one of the backend has failed or the writer role has been migrated to a different server. And of course, this is for multiple cluster topology, so you can have a standard MySQL asynchronous replication, or you can have group replication, Galera, Aurora, etc., etc. So it is able to support all those clustering solutions. One common use case for ProxySQL is also for security, because basically you can have ProxySQL authenticating the client instead of the backend authenticating the client, and then with the features that I'm going to describe later on, it will become more easy why authentication is important. And also it is used for data masking. There was a session this morning about data masking and MySQL dumper, but also ProxySQL can be used for data masking because one of the features of ProxySQL is query write, so you can rewrite the query from MySQL dump to be some function that extract data from the database and on the fly rewrite them. And it also allows to filter traffic. So because it's able to recognize a query, you can specify if you want a query to be allowed to be executed on the backend or not. Sit in the middle between the application and the backend, so it's able to analyze all the query passing, so it allows also to have observability. So in real time, you're able to understand what queries are going to the database and how they are performing. So here is a list of the reasons that ProxySQL is able to improve performance. So connection pooling is absolutely one of the first one, the ability of using few backend connection to handle a very large number of front-end connection. Query routing, so based on the traffic, based on the query, it is able to route traffic to different backend, different clusters. You can have routing based on schema, based on username, based on specific queries, or a specific keyword inside a query, and so on. It also have the ability of rewriting query. One of the features was implemented was query caching, so is able to cache query directly on ProxySQL without the need for the query to reaching the database server. High availability and failover, I mentioned this previously. And one of the things to remember about ProxySQL is that it's a reverse proxy, and as part of this concept, it's also relevant to remember that is ProxySQL the one authenticating the client. So the client has to authenticate to ProxySQL, and then when the client sends query to the proxy, then ProxySQL will decide what to do such query. Okay, next. I mentioned that ProxySQL has query caching. It was always there from the very beginning. It has some limitation by design. So like by design, the query caching ProxySQL is based on TTL. So this means that once ProxySQL is identifying a query that you configure it to be cached, we'll cache it for a certain period of time, and ProxySQL will continue serving that specific result set for a specified amount of time. That is the time that you specify in the configuration. This means that if the data change on the database server, you are still getting stale data from ProxySQL because it's based on TTL. If instead you would like to have real-time cache, instead what we recommend to our users is to use Rediset. There was a presentation this morning. It was describing very well all the characteristics of Rediset. And yes, using Rediset is very, very useful and can drastically cut costs. Okay, now let's go on the first light topic. performance enhancement in 2.6 and 2.7. So there are 3 areas of improvement, performance improvement in those versions. One is that we always strive to keep all our dependency created, so every time there is performance enhancement, we apply for it. The code has been refactored here and there, so we regularly run benchmark, and when we identify some specific workload that need performance improvement, we apply that to it. And another thing interesting that we found out and we fixed in the latest release, 2.7.2 actually, is compression. There was a report some time ago in which basically a user has identified that when using ProxySQL compression, performance were quite bad. Apparently, the main problem was that the ProxySQL by default is using the compression level of zlib, that is compression level 6, while MySQL compression is 3 by default. So it was a huge difference. So now we have the ability of choosing the compression level. The default now is 3, so ProxySQL will have the same performance as MySQL when it comes to compression. Okay, next. Improved usability into 6. We have made a lot of changes. So historically, ProxySQL was, for group replication, was using the script written by Fred years ago. This is not true anymore. Now we support MySQL 8.0 natively, and also for MySQL 8.0 we support auto discovery. This was not there, and now is also available into 6. So if you're using group replication and you're adding new server, ProxySQL is automatically able to detect this without you needing to configure the server. If you're using MySQL router, that MySQL router has the bootstrap option. Now ProxySQL has the bootstrap option as well for group replication. So you can run ProxySQL with -- bootstrap exactly like doing the group replication, and it will automatically detect all the settings related to group replication. We did also more improvement on usability with AWS, both Aurora and RDS. So in Aurora, historically, when ProxySQL was able to detect a new server, in Aurora was setting some specific attribute like maximum number of connection based on the servers of the other server in the same host group, while now this is configurable through host group attribute tables. So you can configure that beforehand. And so new server discovery will get in place there. We also support our discovery for RDS multi-AZ cluster. This is something relatively new in RDS, so we are able to support it as well. And another very important features that we have in 2.6 is something that has been asked many times also here, the preFOSDEM, is the ability of having just one writer, for example. And now we can do this because we have max number of online server on a per host group server, on a per host group basis. So you can say that if you have host group 1, that is where is supposed to be the writer, you can specify max number of online server to be 1, and if they are 2, for whatever reason, ProxySQL will stop sending any sort of traffic to that server until you correct that configuration. Okay. Other improvement that we made into 6, we finally support properly show warning. So warning was not working properly previously, because of the way ProxySQL enabled multiplexing. Once a query was executed, then the backend connection was made available for another client, and ProxySQL was intentionally forgetting all the warning. While now instead, if there is a warning, ProxySQL is able to correctly send show warning to the right backend. Prepare statement. ProxySQL, the way it handles prepare statement is quite complex because it has a metadata caching of the prepare statement, and they can use quite a bit of memory. It really depends from your query pattern. Now we have also statistics about the preFOSDEM memory usage. So it was quite common that ProxySQL was using a lot of memory for preFOSDEM. So finally, it's possible to have those metrics. Now, another interesting feature of ProxySQL that was there from the very beginning was the ability of pausing it, so the ability of stopping the listener. And this was a feature that was regularly used by companies when they want to, for example, migrate from one ProxySQL version to another one. They were stopping, they were pausing ProxySQL, and they're running another one in parallel. So the new proxy was getting the traffic, and the old one was still serving the current connection, but not serving any more new connection. Now we have a variable that shows if ProxySQL is in pause state or not. Another usability improvement is the ability of so we have TCP keep alive enabled by default for client connection. For backend connection was always there, but for front-end connection was not enabled by default. So now it's enabled by default also for client connection. In case ProxySQL crashes, by default what it's doing is restarting. We had a situation in which there was a ProxySQL database corruption, and ProxySQL entered in an infinite restart because the database was corrupted. So now there is this restart with the exponential cutoff. So it doesn't restart at the time. We have also DNS cache. This was introduced into 5, if I remember correctly, but is highly tied with monitoring. So now if monitoring is disabled, DNS cache is disabled as well. Now next, security improvement into 6. We finally have caching SHA-2 password enabled for client connection. So for backend connection, we had caching SHA-2 from very long time, but for front-end connection, we only had the MySQL native password. Now we support also caching SHA-2. And this means that currently ProxySQL allow client and backend to have different authentication plugin. So for instance, you can have the client that's using MySQL native password to connect to ProxySQL, and then caching SHA-2 to connect to the backend, or vice versa. The client can connect to ProxySQL using caching SHA-2, and ProxySQL can connect to the backend using MySQL native. So if you still have a very old client and a very new MySQL server that doesn't allow any more MySQL native password, you can use ProxySQL to let the client connect to ProxySQL using native, and ProxySQL to connect to the backend using caching SHA-2, or vice versa. Maybe you have a very new client driver and a very old server, like you can mix and match however you want. So this also means that we deprecate one variable, that is the admin hash password, because now the passwords are not automatically hashed using the MySQL native password, but instead they are hashed in whatever format you are using them. So now ProxySQL need to have if we want to use caching SHA-2, you have basically two options. You either take the password from the MySQL server and you put it in ProxySQL, and this is what ProxySQL does in the bootstrap mode when you get this information from group replication, from server in group replication. Or you can add your own password directly in ProxySQL, and we also added 2 new functions that are used for generating those passwords. So you can use either MySQL native password or caching SHA-2 password in ProxySQL to generate passwords. Okay, next. Another important thing that security improvement that we did in ProxySQL 2.6 is a new configuration table called MySQL Server SSL params. This allows to set the SSL parameters specific for each server. Apparently, Google Cloud, Cloud SQL, in Cloud SQL, each server has its own certificate and share across them. So you need those settings that are on after host base. Okay, next. Now, in 2.7, we have two major user-driven development, specifically the support of the Proxy v1 protocol, and that this was sponsored by DigitalOcean. They made a blog post about it. I'm going to get into more details soon. And also real-time in-memory and on-disk database query logging. And this was sponsored by Google. So let's get into details about those two features. So like the first one is the proxy protocol. So I have been asked many times to support the proxy protocol between ProxySQL and the backend, but of course I always explain that this doesn't make sense because the database should not know what is the IP of the client, because one single backend connection can be used by multiple clients. So having the IP of the client in the database server doesn't really make sense, and is also misleading because it's not the correct information to have. But we got the request of having the proxy protocol between the client and ProxySQL. So this means that you can have a load balancer, a network load balancer between the client and ProxySQL, and ProxySQL will know which is the IP of the client that is connecting. Because historically, if you have a load balancer, ProxySQL will only see the IP of the load balancer. Now, instead, ProxySQL will be able to see the IP of the client. And this means that from ProxySQL itself, you will be able to create rules that apply to specific users and not to others. You are able to identify which are the users that are sending one specific type of traffic, and you can make any sort of you can take any sort of action like stopping a specific users or writing specific queries and throttling and so on, or just getting the person on call for that specific service. So yes, this improved a lot, both observability and security, because now also from a security point of view, we'll be able to identify which is the client. DigitalOcean wrote a very nice blog post detailing all this. For the proxy protocol, we introduce one new variable, that is the MySQL proxy protocol network. This is a comma-separate list of IP or subnet mask. So here we basically specify which client are allowed to connect to ProxySQL using the proxy protocol. In other words, the IP or the IP range of the network load balancer. Now, next feature is a real-time in-memory query logging. So this came from a specific This was a specific request from Booking, so they needed to analyze exactly, to sample data and identify if there were errors, what type of query were generating errors, and so on. I don't want to get into too many details. So the solution we come with was to have the ability of logging all the queries directly in memory instead of logging them on a database, instead of logging them on a file, because historically ProxySQL was able to already to log query on a file, on a log file. Now is able to log queries directly in memory, and the way it is implemented is that all the queries are logged on fixed size, configurable fixed size circular buffer. So every time query comes, the query is being logged in this circular buffer. The fact that it's a circular buffer means that once it is full, basically queries are being updated within this buffer, so you don't end up in a situation in which all memory is being utilized. And then you have the option of dumping the data from this circular buffer into SQLite, either in memory or on disk. And then you can use the admin interface to query those tables, and you can do any sort of query, like you can aggregate data, you can delete data if you want, and so on. Of course, there are settings to make sure that you don't abuse memory usage. So we have constraint on how much memory those tables can hold. Specifically, there is a bunch of new variables for these features. So the first one is MySQL event log buffer history size. That is basically the size of the circular buffer, then the table memory size. When you are dumping data in memory table, you specify how many rows this table can hold. Anything that goes beyond that threshold is just automatically removed. And then we also have the option of automatically syncing those queries from the circular buffer to the database file on disk automatically, so without the need for commands to dump this information. And this is using the MySQL event log sync buffer to disk. So you specify a time threshold in second, and ProxySQL will automatically dump those tables into this file. Here is an example of how to use it. The example is very generic, like just define that the circular buffer is quite big. This means it can hold up to 1 million query. Big or small, it really depends from your traffic. Like if you are running hundreds of thousands of queries per second, this will be able to hold just 10 seconds of queries. Instead, if you have 1,000 queries per second, of course, this will hold a bit more than 15 minutes. So it really depends from your specific usage. Then the second command is just enable logging of all the query, because otherwise you need to specify on a query basis what you want to log, and then you just apply the setting. And once you run load MySQL variables to runtime, the setting apply, and ProxySQL will start logging all the query. Okay, we also introduce new commands, basically dump event log from buffer to memory, and from buffer to disk, and from buffer to buffer. This means that with one single command you can copy the query to both in-memory tables and on-disk table. The two tables are listed there. One is called start MySQL query event, and the other history MySQL query event. The one on disk, of course, means that it survives any sort of crash, restart, and so on, while the one in memory, if you restart ProxySQL, is gone. Now, if you are familiar with ProxySQL, you know that all the tables in stat schema, they are read-only, and they are automatically generated every time you are querying them. This is the first the first table that is writable, and thus is not regenerated automatically. So this means that if you run multiple query against the same tables, you get the same result. Well, this is not the case with any other stats table. We have also exported a lot of metrics related to these features. I guess you're familiar with the fact that ProxySQL has also a built-in Prometheus exporter, so we are able to export all those metrics through Prometheus. This is the name of the variables in the Prometheus exporter. Instead, if you are querying this table stat MySQL global, the variable name is not exactly the same, but very similar, so you will be able to identify that. And for some of those, we also have a tag, so like to specify if it is related to memory or this. Okay, I think we are short of time, so let me go quickly. It's because I want to reach T7. Okay, so what is new in ProxySQL 3? ProxySQL 3 is basically a completely rewrite of ProxySQL. So we modify the code base a lot, and while refactoring of the code base, the reason why we modify all the code base was to create several layers of abstraction and using C++, polymorphism, and so on to be able to support both MySQL and Postgres at the same time. So yes, we are now supporting Postgres as well. We have some users that are already using it, and they seem very happy. Also because the way ProxySQL is configured for Postgres resembles a lot the way we configure MySQL. So you know all the tables that are called MySQL server, in Postgres they are called PGSQL server, MySQL user become PGSQL users, and so on. Okay, finally, please have a try. So for try 2.7, that hopefully is our latest of 2.7, and we want to focus on 3.0 moving forward. Again, all the code base is on GitHub, and documentation is on our website. Question?
Feature parity between two and three.
Okay, so everything we have in 2 you also have, with the exception of the latest complete, because they have to be ordered, but within a week, everything should be perfect.
Regarding Postgres, will it be possible to connect the client using MySQL to Postgres?
Okay. There is a prototype that they wrote like 2 years ago. It was like a prototype doing this, but right now we don't. Sometime in the future, it was there.
Yeah, so I think last year there was like announcement what MariaDB will kind of support as an old version of a max scale after it's kind of age out from from VSL become PPL. Did you see that any impact?
This prototype you mentioned to proxy from one prototype to the other, will it include like if variations in SQL syntax, or it was still expected to write SQL for the actual backend data?
You're thinking about the proxy protocol?
No, you mentioned based on the previous question.
Yes.
You're going to proxy between.
What you're mentioning is the problem. Like, it's not just a matter of translating the protocol, but supporting everything else. Just to throw an example, there is no documenting Postgres. The concept is not that. So, like, doing the mapping is going to be a long list of limitations.
Just to make sure, so Proxy 3 is GA for MySQL, right?
Yes. We, as I was mentioning before, we make a lot of code change, but we are quite confident for MySQL still GA because we have a huge test suite. So we run a lot of testing. So we are quite confident. Yes.
For an enterprise version with accounts using PAM or LDAP authentication plugin.
We don't have for PAM, we have LDAP.
Yeah.
We have some specific plan, like we have the plan of releasing it, but not open source, but free. So we don't have a specific plan, but we have LDAP support.
Is it possible to play the workload to servers? So if you wanted to test production workload, obviously the production workload goes to the production server, but at the same time, it would go off to a tested server.
We have a lot of things for this. So we have mirroring, for example, and we also have the ability of sending just a percentage of traffic to a different server. But those are two completely different approaches. So it really depends on the traffic. Like if it is a write traffic, you want to send all the write to the writer.
Yeah.
And you might mirror to a different server and see how it's behaving. In case of load balancing with different percentage, you can send it to one reader and a very small percentage to a different reader. And we also have this option with the writing queries. So let's say that, for example, you want to see how a query behaves when it is being rewritten. You can send the original query to one server and the rewritten one to a different one, to a different server, and you compare the execution time.